Now let's look at a few problems from the last few sections that are a little scrambled up here. Notice that the first problem does not have absolute values in it, so we're not going to use what we just did in the last section, but it does have the word "and" in it. We're going to need to clean up and solve each inequality separately. So let's begin by subtracting 2 on each side of the first one and adding 8 to each side of the second one. That will give us x is greater than or equal to 3 and x is less than or equal to 11. Now we need to compare these and use the word "and," which represents an intersection. Our two key numbers are 3 and 11 here. We have a greater than or equal to 3, so solid dot to the right, and we have a less than or equal to 11, which means solid dot and to the left. And says, where do these intersect? Where do they overlap? And the answer is between the 2 points and at those endpoints. So our solution set here is going to be the closed interval from 3 to 11. And again, the closed interval, when I use the word closed, it means I am including both endpoints. For this next problem, I see absolute values, so I want to isolate them on the left before I do anything else. So let's subtract 4 on each side. We have the absolute value of 3x minus 2 is greater than or equal to 13. And now we've got to use one of the properties to remove the absolute values. This is saying distance is greater than 13 units away from 0 on the number line. So that can either happen off on the far left or the far right of our graph. So 3x minus 2 is less than or equal to negative 13, or 3x minus 2 is greater than or equal to 13 itself. Now let's solve each of these by adding 2 to each side. This will give us 3x is less than or equal to negative 11, or 3x is greater than or equal to 15. Dividing each side by 3, we have x less than or equal to negative 11 thirds. Because we divided by a positive 3, we do not change the direction of the inequality. Or we have x is greater than or equal to 5. Writing this in interval notation, we have negative infinity to negative 11 thirds, inclusive of that right endpoint, united with 5, which we include, on up to positive infinity. We conclude with another problem that's joined by or, and let's solve each of these inequalities separately. On the first one we will subtract 5 on each side, and on the second one we will subtract 1 on each side. This leaves us with 3x is less than 12, or negative 2x is greater than negative 4. Now we want to divide off the leading coefficient, so we will divide the first one by 3 and the second one by negative 2. And since we're dividing by a negative, we're going to be careful to change the direction of the inequality. We now have x is less than 4, or x is less than 2. Both of these have less thans. They're joined by the word or, so we want to do a number line analysis here, and our two key numbers are 2 and 4, and both of them have a less than symbol, so both of them will be open circles with the graph shaded to the left. Or says unite these two graphs together, or which values on one graph or the other, and the answer is there is an x value in either of them when we look at x less than 4. So that will be our solution set as graphed, and in interval notation this will be from negative infinity on up to 4, which we do not include.